Yes. So previous class about interpreter and compiler discussed. Interpreter, compiler topic discussed. Yes, Java depends on both compiler as well interpreter. The topic completed. Yes, today topic. About today topic. Yes, today. Yes, about Java features. Java is an independent platform. Yes, Java is an independent platform. Java is an independent platform. Java is independent platform. Yes, what does it mean? What does it mean? What does it mean? Java is independent platform. What does it mean? Let us see. Java is an independent platform. Yes, what does it mean? Let us see. Yes. Yes, Shivendra Kumar resigned. Shivendra Kumar resigned the session. Resigned into session. Yes. Yes, you were in offline. Yes, Shivendra Kumar resigned the session. Yes, facing same issue every day. Facing same issue every day. Okay. Select computer audio while joining. Select computer audio while joining. Select computer audio. Okay. Shivendra Kumar. Yes, rejoin the session. Just rejoin. You are in offline. Facing same issue every day. Select computer audio. Okay. Yes, let us start session. Yes, today topic is yes, Java features. Java is an independent platform. What does it mean here? What does it mean? See, Java program, yes, platform means OS. Here it's a platform means OS. Platform means yes, platform means operating system. Operating system. Platform means operating system. Platform means operating system. Yes, previous class we discussed. OS is a platform, on top of it everything is running. OS acting like a platform. OS acting like a platform. OS is a platform. OS is a platform. On top of it everything is running. So here platform means OS. Okay. Java is independent platform. What does it mean here? Yes, means Java program yes, can run on any OS. That's it. Yes, now question is here, how Java made us independent of platform. Independent of next question, immediate question, how Java made us independent of. Yes, this is important point. Yes, how Java made us independent platform. How Java made us independent platform. Yes, to understand this, first of all about exe file. About exe file. Yes, we should discuss about exe file. Yes, exe means executable file. So what is exe file? See this. What is exe file? What is exe file? About exe file. What is exe file? See, exe file is a binary code file. Today I'll show that binary code. Exe file contains a binary code. It's a binary code file. Yes, it is a system understandable language. It's a system understandable language. It's a system understandable language. Okay. Yes. exe file is a binary code file, zeros ones format. Exe file kind of zeros ones format. That code. Okay, it's a system understandable language. Here's some question for you guys. Some question for you guys. Exe file prepared on Windows OS. On Windows OS. Exe file prepared on Windows OS. Windows OS. Exe file prepared on Windows OS. Can I run on Linux OS? The question. Yes, exe file prepared on Windows OS. Can I run on Linux OS? Yes, anyone can you answer this? What's the answer for this? Exe file. Exe file prepared on Windows OS. Can I run on Linux OS? That's a question. So exe file prepared on Windows OS. Can I run on Linux OS? Yes, for this answer is no. No. What's reason? What is reason for this? Reason is exe file, yes, is a OS dependent. Exe file is OS dependent. Exe file is OS dependent. Okay. See exe file. See, yes, exe file prepared on Windows OS. Can I run on Linux OS? Exe file prepared on Windows OS. Can I run on Linux OS? That is question. Okay, see exe file prepared on Windows OS. Can I run on Linux OS here? No. Answer is no. Reason, exe file is a OS dependent. Exe file is a exe file. Exe file, yes, is OS dependent. Next, immediately question here. Yes, why exe file? Why exe file is OS dependent? Why exe file is OS dependent? OS dependent. OS dependent. Why exe file is OS dependent? Yes. For this purpose, you must have the exe file knowledge. Yeah, they are important questions here. Okay, interview questions, compulsory questions here. Yes, why exe file is OS dependent? That one we should answer. For this purpose, you should know about exe file. Yes, let us see about exe file. About exe file. For example, here, yes, C program, exe file. Yes, executable file prepared on Windows OS. Prepared on Windows OS. Then it contains what? Contains what? Then it contains what does it contain here? What does it contain here? Okay. Yes, C program exe file. Prepared on Windows OS. Then it contains what? Let us see. C program. C turbo C. I'm starting C program. Yes, this is C program. C program. Yes, 1 second. Yes, this is C program. Yes, Alt C, compile, run. It's working fine. 10, 20. First number, second number, 10, 20. Addition, subtraction, multiplication done. Completed. Yes. How it's working actually here? What is happening in the back end? Yes, it's a Turbo C IDE. What is happening in the back end? Let us say about back end process. Yes, C drive. Yes, Turbo C installed here. Turbo C installed. Yes, bin. Inside of bin, all the programs saving. Yes. What is program file name here? Program file name is math.cpp. Program file name is math.cpp. CPP means C++. C language same. Compare the same here. CPP, C++. Math.cpp. See here, it's a math.cpp. Okay. Yes. Once let me delete all of these things. Yes. Now it's a math.cpp file here. Math.cpp. See file saved. Saved. See math.cpp 750, right? The timestamp changed. Time of last modification. Yes, 1/3. 1st March. 1/3 means 1st March. 1st March 2022, 7:50 p.m. Yeah, this is time of last modification. Edit Yes, see this program to add, subtract and multiply two numbers. So this is a program. Okay, fine. Now what I'm doing here, first of all, I'm compiling. See this. When I'm compiling, what happens in the backend? Just observe backend. Compile, program compile. See this here. Yes. Some math.obj file generated. Math.obj. See this .obj file. Math. Yes, .obj file. So what is exactly this obj file? This obj file contains C program. See, this is our C program code, right? Yes, main function. That main function, main program code. Main program code, right? Okay, that program. Yes, your C program converting to binary code and write to .obj file. Writing to .obj. Okay. Yes. 1 second. One second. 1 second. Just someone is asking help to join. Yeah. Now say this. The C program. Okay. C program. Yes, main function. Yes, for the C program, this C program converts into binary code and write into .obj file. Math.obj. This math.obj file contains binary code for our C program only. Okay, right? Binary code for C program. Next, apart from this, there is a predefined library. stdio data and conv data set file. stdio and conv data set file. stdio and conv data set file. These header files also having its own binary codes. These header files also having its own binary code. These header files also having its own binary codes. These header files are having its own binary codes. Okay, fine. Yes, for your C program binary code is math.obj. This is your C program binary code. Okay. Yes, for this, next on it. Now try to observe changes in the backend here. Now when you run this program here, you see this math.exe file created. Application.exe file created. Exe file math.exe file created. Properties. Check it here. .exe file. Executable file. Ready to execute. Okay, executable file. Ready to execute. Application.exe file created. The .exe file created, right? So .exe file created. See, at the time of creating .exe file, what happens here? .exe. How the .exe generates? How it generates here? How the .exe file generates? Okay. See here. C compiler taking binary code for our C program. Math.obj file. Binary code for yes. C library. Binary code for C library. Yes. So binary code for C library. Binary code of your C program is the .obj file. Binary code for C library. Next, binary code for OS library. By linking all of these in generating exe file. So finally, that exe file contains binary code for your C program, that main function and all this. Okay, binary code for your C program. So binary code for that C library and binary code for OS library. By linking all of these things, generating exe file. Okay, C program exe file prepared on Windows OS, then it contains C program exe file prepared on Windows OS, then it contains binary binary code for C program, binary code for C program plus binary code for C library, means that stdio data chapter files. C library plus binary code for OS library, binary code for what is OS here? Windows OS library, binary code for Yes, Windows. Windows OS library. Windows OS library. Okay. Yes, by linking all of these generates exe file. Okay. C program exe file prepared on Windows OS, then it connects binary code for C program, binary code for C library, and binary code for OS library. By linking of all of it generates exe file. So here exe file, yes, linked with yes OS library. Okay, exe file always links with OS library here. Exe file links with OS library, OS library at the time of generating, at the time of generating, exe. That's it here. That exe file is linked with OS library. Exe file is linked with OS library. Okay. Yes, it is called as static linking. Yes, it is called as static linking. Statically linking. It is called as statically linking. It's called as statically linking. It is called as statically linking. Okay, statically linking. That exe file links with OS library at the time of generating exe. At the time of generating exe, it is called as statically linking. It is called as statically linking. It's a statical linking. That's it here. Okay. Yes. Now, this is one example. Let us take Linux, Windows. This Windows example, Linux. C program exe file and Linux base. Let us see Linux also. Let me show Linux. Yes. C program on Linux base. Let us see that also. Yes, in Linux you can see very clearly. Yes, see here Windows base Turbo C. Behind of Turbo C, everything is happened. Behind of Turbo C, automatically happen everything here. But everything. Linux, you have to create exe file manually compilation and creation of exe file, everything is manually. Yes, in Linux you can understand very clearly what is exactly exe file, in Linux ways you can understand very clearly. Okay, let us see Linux ways. Okay, C program on Linux ways, let us see this is some login, just login users, support demo login. Yes, Linux base. It's Linux base. Okay. So next example. Yes, C program exe file prepared on Linux base. Yes, C program exe file. Next example. C program exe file prepared on Linux base. Then it contains binary code for C program, binary code for C library, binary code for Linux base library. Okay. Yes. See, opening terminal, Linux terminal. See here, touching working directory something ls. Yes, here this is mn raw directory. cd mn raw. Change of directory mn raw. Change it to mn raw. Yes, you guys don't think about Linux base. Our topic is not Linux base. Our topic is about exe file. Our topic is about C programming and exe file. Okay. Yes, you guys don't think about what is PWD, what is ls, what is cd. It's not necessary for us. It is not necessary here. See PWD mn raw in these files. Screen cleared. PWD mn raw in that. These are the files. 1 second. For understanding purpose, let me remove some files. Remote. Yes. Start.o. Yes, remove rm means remove. Yes, remote here. Yes, mn raw. Yes, this ls. Only C program is there. Test.c program. Test.c program. Zedit like a Windows notepad. Zedit is like a Windows notepad. Zedit is a notepad. Editor. Okay. Test.c. Yes, opening that C program. See here. Hash include here also library, including header file, main function, a equal to 10, b equal to 20, next int c, next c equal to a plus b. So addition, subtraction, and multiplication of two numbers. Same example here also. Yes, how it's working. We close this notepad. ls, see that, test.c. ls means list of files, ls means list test.c. Now this C program you have to compile. One second. Yes. Suppose some mistakes. There are some mistakes. Suppose here semicolon missing. Suppose here comma missing. Okay. Suppose here something like some bracket missing. Okay. Here double quote is missing. Save. Control S. Save it. After saving, now let us compile. First compilation. Like a Windows, here also compilation. GCC means C language compiler. -C compile option. Yes, test.c. GCC -C means only compile. Just it's compiling now. Compiling. See this all the programs from top to bottom. See previous class we discussed. Compiler shows all the errors from top to bottom. Okay, interpreter is only one error. Interpreter is only one error. But compiler shows all the errors. Compiler shows all the errors. See this error at 8th line. So error at 12th line. Error at 14th line. Next 18th line. All the errors. At 23rd line. All the errors from top to bottom. Compiler all the errors from top to bottom. Compiler shows all the errors from top to bottom. Now correct all the errors. Correction of these errors. Semicolon. Okay, next here it's a comma. Here it's a comma. Yes, next here bracket. Okay. Yes, next here closing double quote. That's it. Save. Control S. Saved here. Saved. Yes, after saving, no recompilation. GCC -C test.c. Yes, recompile. No error. If no error, generated test.o. So like object file. Same like a Windows files. Here math.obj file, right? Like Windows files math.obj. Like math.obj in Linux, yes, test.o file. Object file. This object file contains this test.o. This object file contains binary code for C program. Binary code for C program. That means this part. That main function. Afterward, this part. This part. Binary code for C program. Next, stdio data header file. This also having its own binary code. This header file is having binary code. Okay. So test dot that object file generated. Object file generated. After that, now creating exe file. GCC-o. Okay. Yes, exe name is project. That result exe project or any name. Yes, some any name you can use the result exe name. Suppose projects. Test.o. Yes, what happened? GCC means C language compiler. C language compiler taking test.o file. Taking your program object file means binary code for your program plus binary code for C library stdio data header file plus binary code for Linux OS library. By linking all of this in generating exe file. The project result exe. Result exe is project. Now run it /project. Yes, outputs. Addition, subtraction, multiplication. That's it here. Okay. That project exe name. That exe name can be anyone. Suppose I'm using some name. Suppose Durga. Durga, yes. That exe file by name Durga generated /Durga. Same. Yes, addition, subtraction, multiplication. That's it. Exe file generated. Okay. How that exe file generates? See, at the time of generating exe file, see this. This step to create exe file. GCC. C language compiler taking test.o means binary code for your program. Next, binary code for C library, binary code for OS library. By linking of all of this in generating one project exe file. That project exe file generated. Project exe file generated. Now run it /project running. Yes, see this. Addition, subtraction, multiplication. Yes. Now let us check this project exe file. The project exe file. Zedit project. I'm opening that file here. Project exe file I'm opening here. Exe file opening. Here I'm opening exe file. Yes. Now we can see the coordinates of exe. Yes. It opened it. Exe file opened. Exe file opened. Exe file opened, right? Yes, that exe file, all this binary code. 0s1 format. It's exe format. It's a system understandable language. exe format. It's a system understandable language. It's a system understandable language. exe file. The project exe file created, right? Okay. How that exe file creating? See here. exe file. See, C program exe file prepared on Linux base. Then it contains binary code for C program, the test.o file, binary code for C library, stdio data center file, binary code for Linux OS library. By linking all of this in generating exe file. Yes, that exe file contains what binary code, zeros ones format. Okay. Yes. See this. You can check the exe file. See, in Linux there is a file command. Linux there is a file command to check the type of the file. Suppose test.c. See, file command to check the type of the file test.c, test.c source ASCII text, C source ASCII text, test.c. It's a C source file ASCII text, right? Same thing file command. Now let us check project file, project. See this. Now this command checking type of the file. What is project file? Executable file. It's a executable file. Yes, next it's a Linux based exe file. Executable. Yes, for Linux based generated. See this. This is ld-linux x8664.so.2. This is what? It's Linux library. This is OS library. So here project exe file contains Linux OS library. Yes, this is actually embedded C concepts. Yes, embedded C developer will see all of these things here. Embedded C developer. It's embedded C concept. Okay. That project exe file linked with Linux OS library. See ld-linux x8664.so is a OS library extension. .so is a OS library extension. .2 means is a version. Second version of library here. So this is Linux library. So this project is executable file. Yes, which contains Linux OS library. That's it here. Linux OS library. Okay, so this project exe file is linked with Linux OS library. Okay, yes, see that. Okay, that contains yes Linux OS library. That's it here. So what is happening here? OS library always linking with exe file. OS library always linking with exe file. Let us take one more example. Suppose one more example. Yes, C++ program exe file. C++ program exe file prepared on Windows OS. Windows OS. Yes, Windows OS. Then it contains binary code for C++ program plus binary code for C++ library. In C++ also library something like iOS team data center file. Binary code for yes Windows OS library. Binary code for Windows OS library. That's it. Okay. Yes, that program may be anyone. Exe file may be anyone. That always linking with OS library. If it is generated on the Windows base, links with Windows OS library. If it is on Linux base, links with Linux library. If it is Unix base, links with Unix OS library here. Okay, that exe file always. So you can exe file. Yes, exe file always. Yes, here always link always. Okay. Yes, exe file always links with OS library. Okay. Yes, suppose for example, let us take some example here. Test.exe file. Yes, prepared. Test.exe file prepared on Windows OS. Then Windows OS on Windows OS. Then Windows OS. Then it links. Links with Windows library. Okay, fine. Now test.exe file with Win library. Test.exe file with yes Windows library working on different operations, different platforms or operations. How that is working here? Okay, yes, right. Now test.exe file with Windows library. Test.exe file with Windows library working on different platforms. Let us see. Yes, how it works. Let us see here. Yes, let us take different platforms. Okay. So test.exe file, yes, on different platforms. Okay. Yes, test.exe file with Win library with Win library on different platforms. Yes, let us take different platforms. Different platforms. See hardware, 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 on top of hardware. Yes, Windows OS with Win library, with Windows library, Windows library. Yes, on top of it, now placing exe file, test.exe file, not test.exe, right? Test.exe. Yes, now this test.exe with Windows OS library. So this test.exe file with the Windows library placing on Windows system. After placing in the system, try to run it. Just you try to run it here. Try to run it. When you try to run this test.exe file, that exe file, yes, it will try to call. It will try to call. Yes, call. It will try to call to Win library. Win library. Yes. Yes, since test.exe file linked with Windows OS library. Yes, when you try to run it here, the test.exe file, you try to call Windows library. Yes, available here, available. So test.exe file, yes, it will call to Windows library. Yes, already available here. So link as per linking, it will call Windows library available using that library communication with the hardware. Yes, successfully working. Yes, here working successfully. Working successfully. Now let us take another platform. Yes, on another platform, how it's working. Now let us take Linux platform. Let us take Linux. Linux platform. Yes, Linux base. Linux platform. Linux base with the Linux library. With the Linux library. Linux base with Linux library. Okay, same test.exe file. Same test.exe file placing a Linux base. After placing a Linux base, try to run test.exe. When you try to run test.exe file, as per linking, it will try to call Windows library. See test.exe file with the Windows OS library, with Win library. So when you try to run it, here, now this test.exe file, yes, it will try to call Windows library. Yes, test.exe is linked with Windows library. Since linked with Windows OS library, now it will try to call to Windows library. It will try to call Windows library, but here library is not available. Yes, see test.exe file linked with Windows OS library. Since linked with Windows OS library, it will try to call Windows library, but here library different, not matching. Library not matching. So test.exe file it will try to call. It will try to look for a Windows library here. It's not available. Simply fails. That library is not matching. Library is not matching. Simply fails. Simply fails. Let us take another platform. Suppose Unix base. Let us take Unix base. Unix base with Unix library. Unix library. Same test.exe when you run on Unix base here. Here also same. It will try to call Windows library, but here library is not available. Simply fails. Here also fails. Here also fails because library is not matching. Yes, since library not matching, here also fails here. Yes, here also fails. Okay. Let us take another platform, Mac OS. Suppose Mac OS. Yes, Mac. Yes, Mac and this. Mac is like a Unix base. Mac is like Unix and Linux. Yes, Mac with Mac library. Mac with Mac library. Okay. Now what happens here? Same test.exe will placing in Mac OS. Now same, it will try to call Windows library, but here is not available. Since library is not matching, simply fails. It fails. That's the reason exe file is OS dependent. Yes, since exe file contains OS library. Yes, exe file with OS library. Exe file always always. Yes, always links with OS library. Since exe file is always links with OS library, it's a OS dependent. See here this question. Yes, why exe file is OS dependent? Reason, yes. Yes, it links with OS library. It links to OS library. Okay, it links with OS library. It contains OS library. Yes, since it contains OS library. OS library. Yes, it is a OS dependent. That's it. Simple answer. Yes, you should answer like this. That's it here. Yes, since exe file contains OS library, since exe file is linked with OS library, it's a OS dependent. That's it here. Why exe file is OS dependent? Reason, simple answer, it contains OS library. Simple answer, it contains OS library. It contains OS library. That's the reason it's OS dependent. OS dependent. Simple answer. Yes. Why exe file is OS dependent? Simple answer. It contains OS library. It contains OS library. That's it here. It contains OS library. That's it. Okay. So that is about exe file. Okay. Now let us come to Java. Same concept in Java. Now let us come to Java programming. Yes, let us come to Java. Yes, same Java. How Java program is working? Yes, let us see about Java. How Java program is working here. Okay. Yes. Same example. Let us take Java. Java. Yes, Java program. Yes, Java program. Everything is dot class file. Java program dot class file. Java program dot class file. Java program dot class file prepared and Windows based. Then it contains, yes, bytecode for Java program. It's a bytecode, not binary code. Bytecode for Java program. Bytecode for Java program. Next, bytecode for, yes, bytecode for Java program. Bytecode for Java library. Like a C library, Java, there is a library. Java library. Java library. Okay. Next, binary code for OS library. Next, binary code for OS library. No, don't have this much. Only this part. That is dot class. See, dot class. Java program dot class file prepared on Windows based. Then it contains bytecode for Java program, bytecode for Java library. Java library also developed in Java. Java library also developed in Java. That means it's a pure Java program. Okay, so Java dot class file, dot class file, dot class file is a pure, yes, pure Java program, pure Java program in byte format, in byte format, byte format. Okay, yes, it don't have any OS library, don't have any OS library, it don't have any OS library. Okay, any OS library. Okay, yes, it is free from OS library. Yes, dot class file, it is free. It is free from OS library. It's free from OS library. It's free from OS library. That's it. So dot class file is free from OS library. Dot class file, it is free. Okay. Yes, it is free from OS library. Okay. See, dot class file, yes, is a pure Java program. Dot class file is a pure Java program in byte formats. In byte formats. Dot class file is a pure Java program byte format here. Yes, it don't have any OS library. It is free from OS library. That is dot class. Okay, now see, suppose tested dot class. Tested dot class file. Tested dot class. Yes, working on different platforms. Working on different platforms. Different platforms. Okay, platforms. Okay, how working on different platforms here. So dot class file prepared anyways. Even prepared anyways don't have any OS library. Dot class file always it is free from OS library. Dot class file is free from OS library. Dot class file don't have. Dot class file don't have any OS library. No OS library. It's a pure Java program. Dot class file is a pure Java program. Pure Java program. Now tested dot class file working on different platforms. Tested dot class file working on different platforms. Tested dot class file. Tested dot class file working on different platforms. Let us see. So different platforms. Let us take these platforms here. Yes. First Windows platform. Let us take Windows platform. Tested dot class file and Windows platform. Windows platform. Okay, tested dot class file. Working on different platforms. Okay. Yes. Tested dot class file. So tested dot class file working on different platforms. So tested dot class, this dot class file placed on Windows OS. Yes, can I run this test.class for directly? Can I run it or can I run it or not? Let us see. Yes, we discussed at the beginning. See this fourth statement. What is the statement here? Yes, every program has to link with Waze library before going to start execution. Yes, C program, C++, Java, Hadoop, Python, all these programs linking with Waze library. After linking, then communicates with hardware. Suppose C and C++, yes, is statically linking. Yes, at the time of generating exe file. Yes, already showed. Okay, exe file, that exe file. See exe file. That exe file contains Waze library. See this project exe contains Waze library. So Waze library already linked to project exe file. It's exe file. That Waze library linked with project exe file. This is statical linking. Already linked. Already linked here. Runtime using. Already linked. Runtime using. But in Java, what happens? It's not linked. In Java, what happens? It's not linked. Test.class free from Waze library. It's free from Waze library. Waze library. Yes, to run the tested.class, first of all, it has to link with Waze library. Without linking, cannot run. Without linking, cannot run. Yet this tested.class file has to link with Waze library. Okay, see this point here. Yes, every program has to link with Waze library. Yes, maybe C and C++, Java, Hadoop, Python. All these programs have to link with Waze library of linking then execution. Suppose C and C++ is yes, at the time of generating exe file itself linked with Waze library. But Java program is not linked. Okay, yes, Java program tested dot class file. Can you execute dot class file? No, we can't execute directly. But the tested dot class file, we can't execute directly. That has to link with Waze library. We will link. If the tested dot class file has to link with Waze library, the tested.class file has to link with Waze library. Yes, to link tested.class file with Waze library, yes, between is to one more layer comes. Yes, one more layer come to picture. Yes, tested.class file has to link with Waze library. Someone has to link. Yes, to link tested.class file with Windows Waze library, one more layer comes. What is that layer? Anyone can you guess it? Yes. So between tested.class file, Windows Waze library, one layer comes. What is that layer? Anyone can you guess it? Anyone can you guess it? Some layer come to picture. What is that layer? Anyone can you guess it? Anyone can you guess it? Between tested.class file, Windows Waze library, yes, one more layer come to picture. MEC. Nishiganda. MEC means model B controversial, that is framework. The framework architecture. I think you confusion. You getting confusion, not MEC. Yes. Try to get that name. Yes. Yeah, right. JVM. JVM will come to picture. JVM will come to picture. JVM come to picture. JVM come to picture. See, here JVM come to picture. JVM come to picture. So JVM taking test.class file. JVM taking test.class file links with Windows OS library. Once linked with OS library, then execution generating output. That's it here. Okay. Now, same test.class file, take another platform. Let us take another platform. If it is running another platform, same test.class file, another platform, another platform, another platform. Okay, another platform. Suppose Linux base, Linux platform with Linux library, with Linux library, Linux base with Linux library. Yes, how it's working here. Yes, now see here also same tested.class file, tested.class file taking by JVM and links with Linux base library. See, if it is Windows OS, the tested.class file is linking to Windows OS library. Okay. Yes, if it is Linux base, linking with Linux base library. Similarly, one more platform, Unix base, Unix base, Unix base with Unix library, right? Now, JVM taking tested.class file, JVM taking tested.class file links with Unix library. Once linked with Unix library, then working here fine. Okay, let us take one more platform, Mac OS. If it is Mac, yes, Mac OS on Mac OS, Mac OS, yes, with the Mac library, Mac OS with Mac library. Yes, here also same happens here. Mac OS with Mac library here. So JVM taking test.class file, JVM taking test.class file links with Mac OS library here. Once linked here, communicating with hardware component. That's it here. So what is happening here? Tested.class file is free from OS library. Yes, tested.class file don't have any OS library. Okay. After placing on the OS, if OS is Windows OS linking with Windows OS library, same test.class file links with Linux OS library, same test.class file linking with Unix library, same test.class file linking with Mac OS library. That means that link changes. At runtime, link changes is nothing but dynamical linking. See, dynamical linking. In case of exe file, that link is fixed. Test.exe file with Windows OS library. Once exe file created, that link is fixed. Static means fixed. Static means fixed. Statically linking. Yes, exe file statically linking. Statically linking with OS library. That is static linking fixed. Once link is done here, it's fixed here. But in Java, what happens here depends on OS. So here every time of changing OS, if that link changes. Test.class file links with Windows OS library, same test.class file linking with Linux, same test.class file with Unix OS, same test.class file with Mac OS. Who will do that here? JVM. JVM. So whenever every time of changing OS here, every time of changing OS, that link changes. That means a dynamic linking here. So dynamic linking. Okay. So Java, see Java tested.class file. Yes, Java.class file, Java.class file dynamically, yes, links with OS library, OS library. Yes, since dynamical linking, it becomes independent of platform. That it's okay. Since it is linking, linking, linking dynamically with OS library. Yes, it's an independent platform. It's an independent of platform. That's it. It's an independent of platform. That's it. Okay. Yes. Now here doubt is here. Doubt. Here JVM is there. Here JVM is there. Here JVM. Everywhere JVM, right? JVM involving. So JVM is the responsible, yes, for dynamic linking. So here, so JVM, yes, JVM is a responsible Java virtual machine, Java virtual machine, Java virtual machine. JVM is a responsible, JVM is a responsible, yes, to make, yes, dot class file, yes, dot class file is an independent of platform, is an independent of platform, independent of platform. That it here JVM is responsible, JVM is responsible. Okay, now question is here, question, JVM, is it part of OS? Here JVM is there, here JVM, here OS JVM, in every way JVM is there. JVM, is it part of OS? JVM, is it part of OS? No, it's not a part of OS. Okay, yes, JVM, yes, is not a JVM. JVM is not a part of OS. JVM is not a part of OS. Then from where getting this? It's from JDK. Yes, it is from JDK, Java software. JDK, it is from JDK. It is from JDK. Okay, then how can you get JVM here? Yes, you have to install JDK. Yeah, to get JVM here, we should install JDK here. Okay, yes, to get JVM, yes, we need to, yes, install, yes, install JDK on the system. That's it. Yes, to get JVM, we need to install JDK on the system. Once JDK installed, that will give me JVM. See JDK installed. See in my system JDK. C drive, program files, Java, JDK installed. JDK bin in this JVM is available. This is JVM. JVM. This is JVM. So once JDK install, getting that JVM, right? JVM. Okay, fine. Yes. Next, one more important point here. See, dot class file is independent of OS, but JVM is OS dependent. See, Java program file Java program file is independent of OS, but JVM is OS dependent. Okay, so next important point is Java dot class program file yes is an independent of platform Java dot class program file is independent of platform, but JVM yes is a platform dependent platform yes means ways platform means ways dependent. That's okay. Java dot class program file is independent of platform. Okay, so means independent of ways. But JVM is a ways dependent. Why? What's the reason here? What's the reason? Why JVM is ways dependent? Reason: JVM is a C++ exe file. JVM is a C++ exe file. Yes, it was developed. Developed in C++. Yes, behind of JVM, C++ program working. Yes, we'll discuss. Java programming, I'll explain. Okay, Java programming. When you're running any Java program, behind of Java program, JVM working. Behind of JVM, C++ code is working. That C++ code, I will tell you. I'll explain with C++ code. Behind of every Java program, C++ code working. How that C++ code working with memory map, I will explain. I have that much of knowledge because embedded C experience. I have embedded C and C++ knowledge. So with that knowledge only, I'm able to understand all of the concepts like this. Okay. So behind of JVM, C++ code is running. How that code is working with memory map, I will explain in programming. Okay. That is my knowledge. My level of knowledge is that much here. So behind of JVM, how C++ code is working, that I will show. Okay. Yes. So you can C++ JVM is a C++ exe file. Exe file means what? Exe file means what? It's a OS dependent. Exe file. JVM is exe. JVM is exe. Exe file means it's a OS dependent. See here. JVM. See JVM. It's application, right? JVM is an application which is exe file. See that. C drive. Previously we discussed TC turbo C bin. Yes, that math.exe file. See this. Yes, application means exe file. So right click, property, check it here. .exe file. .exe file is application means exe file. .exe file. It's a .exe file. Program files. Yes, Java. Yes, JDK. Yes, bin. Bin means binary codes. Binary files means exe files. Binary files, exe files. See, right click, properties. See that .exe. .exe. That binary code file. It's exe file. That exe file prepared in C++. C++ exe file. That's it. JVM is a OS dependent. Okay. Since JVM is a OS dependent, yes, JDK also OS dependent. That's it. See JDK for Windows OS. See here JDK for Windows OS. Here JDK for Windows OS. This JDK you cannot set up on Linux OS. Linux OS is having different JDK. Linux JDK. Same JDK cannot set up on Unix OS. So different operations, different JDKs you have to download. Mac OS, its own JDK. Yes, Windows, its own JDK. Let me show that. JDK for different operations. Yes, download JDK 1.8 Java SE 8 downloads. See that Oracle site. From the Oracle site you have to download. Oracle Corporation. From this site we have to download. See here JDK downloads all the JDKs. JDK for Linux operations, JDK for Mac OS, JDK for Solaris, JDK for Windows OS. Yes, Windows 10. For Windows 10, last one we should download. For Windows 10, last one you have to download. Yes, you guys, you need not download. I'll provide it. JDK 8, 9, 11, 13. These three versions I'll provide. Yes, I have the Oracle account. I have the Oracle account here. So using that, I have downloaded. Same thing we are using for office purpose. Office work. Okay. Yes, same JDK I'll provide you. Yes, you guys don't worry. You need to download. Same JDK I'll provide it here. You need to download. Okay. Yes. So this is JDK. So JDK, yes, since JVM is OS dependent, JDK also, yes, OS dependent. That's it. That is independent of platform. Yes, how Java made us independent of platform. This is clear explanation. Practically about EXE practically explained. Okay. Yes, about JVM. Yes, about Java program. What is happening Java program? Very clearly explained. Okay. Now EXE file dot class file discussed, right? Yes, about EXE file discussed, about dot class file discussed. Then what's the difference between these two? Let us see the difference here. Dot class file EXE file difference. Dot class file EXE file difference. See here dot exe file dot class file difference. Okay, see first difference. Exe file is a binary code. Yes, I showed already zeros ones for binary codes. Dot class is a byte code file. Exe file is binary code file. Dot class is byte code file. Exe is system understandable language. Exe file is a system understandable. Yes, it's a JVM understandable, right? JVM is responsible to run the dot class file. So JVM understandable code that is. So first point this is. Okay. Yes, next difference. See the next difference. Exe file contains program code, software library, and OS library, including OS library. What is dot class? Dot class is a pure Java program. Dot class is a pure Java program. Yeah, don't have any OS library. Don't have any OS library. Dot class is a pure Java program. Don't have any OS library. Yes, it contains bytecode for Java program, bytecode for OS library. Sorry, bytecode for Java library. Java program plus Java library. That's it. Don't have any OS library. No OS library. It is free from OS library. Okay. Yes. Next. See exe file prepared for specific OS. If it is exe file prepared on Windows OS, only running on Windows OS for specific OS, but dot class is not a prepared one. Yes. Here don't have any OS library. Since don't have any OS library, it's not a prepared file. Okay. See OS library statically linking with exe file. With exe file here. OS library statically linking means at the time of generating exe file itself linking. But in dot class, what happens? Runtime linking. Yes, if it is running on Windows OS, links with Windows OS library. Same program running on Linux OS, links to Linux. Same program on Unix OS, links to Unix. That OS library dynamically linking with dot class file at runtime. Okay, so this is C language exe file is statically linking. Java dot class file is a dynamically linking. Okay, right? Yes, next. Exe file prepared one, already prepared, directly running, but dot class file not prepared file. After moving on to OS, JVM prepares as per current OS. Yes, JVM preparing means linking. JVM linking dot class to current OS. That's it. Okay. See, exe file executes faster than dot class file. Exe file executes faster than dot class because exe file is already prepared. In binary code file already linked with OS library. Exe file executes faster. Reason that is already it's a binary code and already linked. So already ready-made file, directly execution. Exe file executing directly here, directly. But when complete dot class file, what happens here? Preparing at runtime. Dot class preparing at runtime means what happens here? Dot class file contains bytecode. That bytecode first of all convert into binary code. That binary code linking with OS library. So what happens here? Dot class preparing at runtime. Dot class file preparing at runtime. So at runtime, what is happening here? Dot class file bytecode. That bytecode converts into binary code. That binary code linking with OS library. So converting and linking happening at runtime. since happening at runtime, slowly running. Okay, not much slow, little bit slow. Compared to exe file, somewhat slow. Somewhat slow. Because preparing at runtime. That's it. Okay. Yes, next one more thing here. Suppose C program exe file. One more important point. Demo. Yes, here that exe file. / project exe file. Running. Yes, here C software. Yes, installed. On this Linux base, C software installed here. That C compiler installed here. After installing C compiler, C software installed here. So we got the exe file. Right? After getting this exe file, move to same Linux base, similar base, Ubuntu base. Ubuntu and first Ubuntu that exe file create. That exe file move to second Ubuntu. After directly can execute. Again, C software not necessary. To run at second Ubuntu, third Ubuntu, fourth, similar ways. Yes, exe file is OS dependent, right? Means same OS and same Ubuntu. To run same Ubuntu, yes, you can run it directly. Again, C software not necessary. That C software installation not necessary. To run the exe file here, yes, that application software, C software not required to install. Okay, to run exe file, direct exe file can run directly. Again, software is not necessary. C software not required to install. Directly it can run. But when come to Java, yes, to run the .class file, to run .class file, JDK required, right? .class file running. See, .class file running on different platforms. Different platforms. Here JVM required, here JVM required, here JVM required, here JVM required. To run .class file, JVM required. Yes, how can you get JVM? JDK. Once JDK install, you can get JVM. That means to run the .class file on every system, you must install JDK software. Yes, the Java environment you have to set up. Without set up the Java environment, Java program file will not work. But C language exe file not necessary. Once exe file created, that will run directly. Yes, C software not necessary. C environment is not necessary. But in Java, every time of running .class file compulsory, the Java environment required. That's it. Okay. Yes, to run .class file. To run .class file, JDK should be installed on every OS. That's it. So this is difference between exe file .class file. That's it. So that's all about independent platform. Okay. See, 1 second. Today topic just to try and Google how Java made us independent platform. To try this one. Okay. Next, what is exe file? About just ask about exe file. About .class file. Next, about difference between .exe .class. Just you ask Google. Search in Google. Yes, you'll get only less information. Most of the websites, Java websites will give very less information. 1 or 2 points. Even Java trainers also, they don't have this much of knowledge. See, my knowledge is different, my experience is different here. Yes, I worked on embedded C. I worked on Linux base. Lot of experience. Okay. I'm sure. Yes, check in any website. You can't get this much of information about independent platform. Next, about exe file, about .class file. Yes, even no trainer will explain this much of thing here. So my experience is more than Google. Even Google also will not give that much of information. I'll give that much of yes, concepts and explanation. Yeah, that is level of my experience. Okay, not only here, going forward we'll see. Okay, see, generally here, most of the trainers beginning class are very interested, but going forward, yes, losing interest. But my classes, day by day increasing interest. Every day increasing interest. When once you enter into programming, more interesting. Programming logics and working Java, day by day increasing your interest. That is my classes and other classes difference. Okay, yeah. So that's all for today. So all this introduction completed. All Java introduction completed. So next topic is yes, Java installation. Yes, all this introduction completed. Okay, so next we are going for installation, installing Java. So this topic tomorrow we'll discuss. Tomorrow we are entering into programming. Yes, tomorrow starting programming. Okay, tomorrow, yes, you have to start setup, Java installation. Tomorrow, after finishing class, you start installation. I'll explain how to set up Java, how to install Java, how to set up Java, next Eclipse, and all that tomorrow we'll discuss. Once the topic completed, you can start working. So after this theory completed, from tomorrow onwards, practical work starts. That's all for today. Yes, any doubts? Yes, guys, any doubts? Any doubts? Yes, you guys see almost and all of these things shared to everyone. Yes, almost everyone paid. Yes, all these 50 paid and taken software. I think except one or two guys. Except I think only one or two guys. Okay. Yes, I don't want to mention their names. Except two guys. Everyone paid. Okay, everyone paid and taken that. Okay, others also. Yes, please finish from your side and try to take JDK software. Yes, tomorrow from seriously, tomorrow onwards you have to start work. Yes, till today, yes, just attended classes, watching classes, theory concepts completed. From tomorrow you have to install. Okay, right? Yes. Okay. Yeah. Nishiganda, good. Thank you, Nishiganda. Yeah. So that's all for today. So thank you guys. Yes, we'll continue tomorrow. Thank you. See you tomorrow.